Today we're going to be working on Leetcode question number 289, Game of Life. According to Wikipedia's article, the game of life, also known simply as life, is a cellular automation devised by this mathematician. And the board is made up of m cross n grid of cells, where each cell has an initial state. Live is represented as 1 and dead is represented as 0. Each cell interacts with its 8 neighbors using the following 4 rules. So these are the rules which we need to implement. Any live cell with fewer than 2 live neighbors dies. So if we have a live cell and the neighbor, if we have a live cell which is represented as 1 and it's within its 8 neighbors, if it is less than 2, meaning 1 or 0 neighbor, and this is the 1 is gonna get converted to 0. And then the second point is any live cell with 2 or 3 live neighbors lives on to the next generation. If we have a 1 and the total number of live neighbors is either 2 or 3, that is gonna stay 1. Third one is any live cell with more than 3 live neighbors dies. If we have a 1 and the neighbors are more than 3, 4 or 5 or 6, that one is gonna get converted to 0. Any dead cell with exactly 3 live neighbors become a live cell. So if there is a dead cell, which is gonna be, if there is a dead cell and it has exactly 3 neighbors, 3 live neighbors, then that 0 is gonna transform to 1. What we're gonna be doing is, like, initially we have been given an array of 0 or 1, right? So because we don't want to use extra space and we do want to make changes to the same one, what we do is, like, we change. If we do want to change the value, first of all, if the value is not getting changed, right, or especially if the value is 0 and it stays 0, we don't want to touch that. But if the value is, let's say if the value is 0 and it wants to become 1, we will change the number to 1 0, meaning 4. Sorry, 1 0 is like 2, right? 0, we don't want to change anything. If it is 0 and it wants to say 0, 0 and staying 0, don't want to change it. We don't want to mess with it. If it is 0 and if it wants to become 1, we will make it in binary. We'll make it 1 0, which would be equal to 2. If it is 1 and it wants to stay 1, it should stay 1, we're gonna change it to 1 1, which is equal to 3. These are the only transformations we're gonna be doing. If it is, yeah, and the other one is if it is 1 and it is staying, it's gonna become 0. We don't want to change it. Why? We have 1 and it is staying 0. In binary it would be 0 1, and it could stay 1, right? So it will stay 1, because in the end, at the end of the algorithm, in the end, it's just gonna right shift everything to 1 so that we can go to the new state. So 1 converting to 0, we don't want to mess with it too, because 0 1 is again 1. That being said, we're gonna have our sanity check here. If the board is equal to null, or the board dot length is equal to 0, we're gonna return. We don't want to do any changes to it. We're good. Okay, we're gonna have our number of rows. Let's call it m is equal to board dot length, and int n is the number of columns, which is gonna be board 0 dot length. Okay, now we're gonna iterate through our like the board. For that, it's gonna be int I equals to 0, I is less than m I plus plus total number of rows. For int j is equal to 0, j is less than n j plus plus. Every single time we're gonna call a helper function, which is gonna be give us how many lives there are in the neighbor. Yes, how many lives in the neighbors are there. So live neighbors, we're gonna give it the complete board, the number of rows, the number of columns, and the current indices. Once we have the live, all we have to do is as we said, there are only two things which we want to change. These two are the ones. So we're gonna say that if the board of ij is equal to 1, right? If it is 1 and the lives are between the lives are between 2 and 3, right? And lives greater than equal to 2 and lives less than equal to 3. And if that is the case, we're gonna say that the board of ij is equal to 3. This is the one. Okay, otherwise if the board of ij is equal to 0, now we want to do this one. 0 and the lives are equal to 3, then it's gonna become alive again. So for that, we're gonna say board of ij has become equal to 2. Okay, once we come out of this for loop, all we need to do is to change for every single element inside the array. We're gonna go to the next state. For int I equals to 0, I is less than m I plus plus. For int j equals to 0, j is less than n j plus plus. The board of I j is gonna right shift equal to 1, and that is it. The last thing we need to do is to implement this function which returns us the live neighbors, total number of live neighbors. So you're gonna have a board, you're gonna have int m, int n, int I, int j. Okay, initially the lives are equal to 0. What we're gonna be doing is we're gonna be going through, because it's total of, we're gonna go through all the 9 elements because in order to check the neighbors, we're gonna be going from the like possibly 9 elements. If it is we're gonna have the limits that if it is going out of the elements range, like the arrays dimension range, we're just gonna ignore that. Otherwise we are gonna we're gonna go through all the 9 elements, and in the end we're gonna subtract the element itself, like that particular ij index. We're gonna subtract that, and that's how we're gonna be calculating the total number of live elements. So for int x equals to, we're gonna say that it is the max between the real, like the diagonally left element. Diagonal left element, it would be I minus 1 or 0 if it is going out of array. Now we want to use it just a 0. And similarly, it's going to be less than equal to math dot minimum between the I plus 1 going to the right diagonal, right top diagonal, and then m minus 1, because we don't want to go out of range. We're gonna do very similar thing to y. Int y is equal to, again, math dot max between uh, j minus 1 and 0. Y should go up to math dot minimum of j plus 1 and n minus 1, j plus plus. So this will go through all the nine elements. Board of x, y, and 1. In the end, we wanna do is like subtract the value of board at ij and 1. If that was a 1, this is gonna get subtracted from the total lives. Otherwise, it's just gonna stay what the lives was. And this is, we are doing it because we only need the lives in the neighbors, not the live at index ij. Looking good. Time limit is exceeded. We gotta check our loops. Okay, the first one is going from I equal to 0 to I is less than m, I plus plus. Second one is going j is equal to j is less than n, j plus plus. Calling the neighbors are good. Okay, now I is equal to 0 as I is less than m. J is equal to 0, j is less than n, j plus plus. That should get us out of there. Now yx is basically equal to math dot max I minus 1 or 0, and then x is less than equal to math dot minimum of I plus 1 and m minus 1, and we're doing x plus plus. Okay, over here we're doing y equals to math dot max j minus 1 and then 0. That looks right. J is less than equal to math dot min j plus 1 n minus 1. Looking good. J plus plus. Okay, now the question is, where exactly is it? Okay, let's just see the lives here. Okay, right. Okay, let's just console log total live neighbors. Oh, this is not JavaScript. It should be system.out.println. Okay, so it never prints that. That means it never comes out of that. So we should have something wrong with the live neighbors, MNIJ. Okay, lives are 0. Or x is equal to math dot max I minus 1 and then j and then 0 less than equal to I plus 1 and m minus 1 between that. Looking good. X plus plus y is equal to math dot max j minus 1 and 0 and j is less than equal to things. Oh, here's a typo. Okay, we're gonna remove that and let's submit that, and it works.